All right, so we're going to do our review for Chapter 9 and the Green Book. Our page number is 641 in the Green Book. So these are the terms that we've been learning, and we've gotten down to number 14. I'm going to skip number 16 and go to number 18, okay? And we're going to just kind of hit the high points here and move on, because I don't want to get bogged down with trigonometry, not at this point, because I just don't want to slow us down any more than we have to. And we'll come back and hit the number 16 geometry problem or trigonometry problem later. And let's look at this. Let's draw our shape. Oh, first off, we got to start off with our name at the top of our paper. So let's put our name here. And today's date is 5/5. Okay. And we're doing Chapter 9 review. And we're on number 18, page 641. All right, so now let's finish drawing out our shapes. So far, I'm going to look at this in sections. We're going to look at this like just like a triangle, only without the other part. So here we got perpendicular lines here. So obviously we have the base and the height of our triangle. If we have the base and the height, we can find an area easily. All right, and so in this case, you would find the area of a triangle based on its height. All right, let's look at our what our question's asking us before we start. It says, find the shaded area. That's going to be this area inside here. Round to the nearest tenth of, if necessary. So basically, it's composite figures. That's what we're doing. We got triangle, and in this case, this would be a parallelogram off to the side. But you could have broken it down into a trapezoid and another trapezoid if you wanted to, but that's too much trouble. So this, you take the area of the triangle and the area of the parallelogram and add them together, and that's all you do. It's very simple. And so we're going to do area of a triangle with a base of 15. Let me move this over so you can see this. All right, the base of 15. Try to get this straightened up for you guys. There we go. And a height of 15. 15 times 15 is 225. 225 cut in half is 112.5, I believe. Let me double check that. So we got 15 times 15 divided by 2 is 112.5. That's right. Okay, so we're good. So that's going to be feet squared. All right, and then now we're going to add to that the semicircle at the bottom. It's this thing right here, and it's got a diameter of 15. Instead of a base, it's going to have from one point to the other, that's called the diameter. So we need to find the area of a circle. The area of a circle is pi r squared, but this is not a full circle. This is a semicircle, so it's half of what a circle's area would be. So there's your formula. So in this case, we're going to put 1/2 times pi times something squared. Well, that something is the radius. The radius is half of the diameter. So from here to here would be 7.5 feet, okay? So I'm going to put 7.5 feet there, and then we're going to work it out. We'll have to use our calculator on this one because pi is not an easy number to use. Second mode clear. I'm going to start off with 7.5 times 7.5, multiply it by pi. Trying to remember where pi is on the calculator. And then we divide everything by 2 because it's a semicircle, and we get 88.4 feet squared. And so when we add 112 and 88.4, we get 200.9, okay? So we get total area of 200.9, okay, feet squared. So that's composite figures. Let's move on to number 20. Let's zip through the review if we can. Now we've got a subtracting situation here. We're taking away, we're cutting out a portion of our shape. It's going to be a triangle, and then we take away or subtract a semicircle. And this time we're changing our units from feet to millimeters, so you need to be careful that you don't change anything there. So we're going to draw our shape. Here's our triangle. Dotted line here because we're going to have a semicircle cut out of that triangle. Now this says this is 2 millimeters, this is 2 millimeters, and then from here to here is 4 millimeters. So if I add all that up, that's 8 millimeters all the way across the base. Now we have to know a few things here, that all three of these tick marks mean that each side is 8, 8, 8. So in other words, if I flip this upside down and kind of focus in on that right there, we can find the area is 1/2 base times height. Now the problem is we know the base is 8, but we don't know the height. We got to figure that height out, because height is perpendicular to a base. So in this case right here, if you break this down even further and look at just this side of this triangle over here, so I'm going to blow that up a little bit so you can see what's happening here. Obviously we have 8 all the way across, but this is going to be 4 and 4 right there for that base. If this is an equilateral triangle, this should split this evenly right here. So you could divide this into 2 chunks, and what happens is you get a right angle here. That's the whole point of this. So in other words, what's Mr. King doing? He's finding this height here, okay? And so we're going to, okay, the height is right here, so I'm going to put H right there. That's what we want to find. We know that this side right here is 8, and we have a side length of 4 also. So we need to find out what this other side is. It's going to be smaller than 8, because 8 in this case would be considered the hypotenuse. So it's going to be, we're going to use the formula a squared plus b squared equals c squared. That's Pythagorean theorem. Pythagorean theorem. Okay, and then now we're going to fill in the blanks. Something squared plus something squared equals something squared. Now that big number C is 8, because that's the longest side. The hypotenuse is opposite the right angle here. Okay, so it doesn't matter where you put the other 2 sides. You could put H here and 4 there. I like to put the small side, which I think is going to be 4, where A is, just because. Just keep it small, medium, large. Okay, so in this case we're going to be 16 plus h squared equals 64, and then we're subtract out here to get the height. So our height squared is going to be 64 minus 16, and we get 48. Okay, so we have 48, and so h is going to be the square H is going to be the square root of 48. Now this is the part. This is a part where you need to understand that you're not supposed to leave your radicals in this form. You need to have your radicals simplified out to the smallest prime number you could possibly have under the radical. So you need to have a number like 2 or 3 or 5 or 7 or 11. You know, anything prime under here, then pull out any perfect squares that you got. Well, if you look at 48, I'm trying to think of some perfect squares easily. Out of 48, so you got 6 times 8, obviously, right? So what I'm going to do is I'm going to do prime factorization. So prime factorization, okay? And so, in other words, what's going to happen is if I divide 48 by 2, then I get 24. If I divide 24 by 2, I get 12. If I divide 12 by 2, I get 6. If I divide 6 by 2, I get 3. So I think my prime factorization is going to be 2 times 2 times 2 times 2 times 3. Okay, so I just kept dividing here. Let's prove this to you. All right. So 2 times 2 times 2 times 2, that's 4 2s times 3 should be 48. See that? So that's called, all these are prime numbers here. So what's going to happen is you got two 2's, that's going to factor out. Then you got two 2's here, that factors out. And what's going to be left is going to be that 3 under the radical. That's the smallest prime number that you could possibly have under the radical. So in this case, it's going to be 2 squared is, this is 4. The square root of 4 is 2. And the square root of 4 is 2. So 4 times 4 is 16, right? So 16 square rooted is 4, and that's my final answer, okay? So that's how that works out. I know it takes a lot of brain power to kind of understand this concept, and this problem is not an easy problem, okay? So the height of this whole triangle, after figuring all this out, is 4 square root of 3, right? So now we're going to figure out, here's the deal. This is a composite figure, so once we figure out the area of the triangle, we are not through. We still have to subtract off the area of the semicircle. So that's what makes this problem so much as far as complexity. All right, so half of 8 is 4. 4 times 4 is 16. So area equals 16 square root of 3. Now I'm going to keep the area of the triangle. I'm going to call this AT for area of a triangle, okay? And then, so the area of your triangle is going to be 16 square root of 3. Now we're going to use that. That's the big number. We're going to subtract something away from that. So now let's come over here to the left and let's block off a little zone here. I'm blocking off a little area so that, that we can work out the rest of our problem for number 20. And so we're going to do the area of a semicircle. So I'm going to put AS for semicircle. And a semicircle is half of a circle. And the formula for the area of a circle is pi r squared. Right, okay, so now the area of a semicircle is going to be 1/2 of pi times the radius squared. Well, the radius of this semicircle is not 4, guys. Don't confuse that. That's going to be the diameter there. The radius would be half of that. So you have, the radius is half of the diameter. So you've got 2, 2. So all the way across is 2, 2, 2, 2. Okay? So the radius is 2. Let's move on. So we got 1/2 of pi times 4. Half of 4 is 2. So this turns out to be 2 pi, right? So 2 pi is what I'm going to take away from this. So now this is where it's going to get really tricky. So I'm going to put a double line there. And I'm going to put the area of the shaded region is going to be the area of a triangle minus the area of the semicircle. Okay, so now what we're going to do is we're going to put 16 square root of 3, and then we're going to subtract off 2 pi, and my answer is done. Okay, so that's how that works. So you take, first off, we had to find out the height of your triangle, which is perpendicular to the base. The base was 8, 2, 4, 2, added all together. Then we used Pythagorean Theorem because we knew all sides were equal to 8. We use these little tick marks. It's called equilateral triangles, and all the above happened. So we've simplified our radical from negative square root of 48 to 4 square root of 3, and then we use that into the triangle formula here. Okay, so now I know this was a lot for number 20. And that's why I wanted to skip number 16, is because I wanted to get to this, which I think is more important as far as the ACT is concerned. I'm trying to be as focused as I can on helping you guys with that, because really that's the one thing that's going to affect your life the rest of your life, okay? You may not think that now, but it really will. The ACT, the more you study for it, the more prepared you are, and the more financial assistance you get throughout your life in college. It will pay for itself the more work you put in, okay? So this is very simple right here. I'm not going to really spend too much time on number 22. We're just going to hit, it's just called the perimeter in the area. I'm just going to basically estimate what this is. It's very simple. I don't have, like I said, I don't have the coordinate paper or grid paper printed off. I'm just going to do this, I can do this freehanded, but I'm not going to spend time working this out freehanded. I'm going to zoom in on this and count these, okay? So I just want you to see on number 22 how fast you can do this kind of problem. It's very simple as far as estimating area. And then we're going to split it off into perimeters. So we got two sections that we have to find. So the area of the shape is kind of like a big composite area. You're going to count all the squares and triangles and all that kind of jazz and estimate. And then right here, perimeter is going to be all the distance all the way around the shape. Okay. So what I am going to do is I'm going to kind of do a freehand sketch of just the shape itself. I'm going to count out the squares here. All right, so what we've got here, it looks to me like we've got a big, just a blob, right? Let me see if I can get this going here. See, I can see this grid. Let me back that up. Okay, now you can kind of see the grid a little bit better. Brighten it up just a little more. Okay, too much, right? Okay, so now this is a triangle right there. Okay, so I want to keep a triangle in my head. What you could do is, you know what would be interesting is if we broke this down into triangles and squares. So I'm going to count the number of triangles that I've got in the entire shape. And over here on my problem, where I'm going to count my area, I'm going to count my area, my triangles and my squares. I'm going to keep a running tally, just watch this, okay? So we're going to keep, this is kind of like a frequency table. Now you can't see this, but I just wanted you to see kind of where I'm going, and I'll go back and explain what I'm doing in just a second. So we've got a triangle here, square there, 2, 3, 4, 5, another triangle. I mean, you could do it like this, you know, and now that would take forever, right? So I think the best thing to do is skip the squares and just count the triangles, okay? And then what we'll do with the squares is we'll calculate the area out, you know, by using an estimated rectangle or parallelogram as need be, okay? So if I look through this, I'm going to see I have one triangle here, another triangle there, 3, 4. Okay, I'm going to follow this line, 4. So I'm keeping my tally mark going here. 5, 6. And then I'm going to follow this line, 7, 8. Looks to me 9. Like that, okay. And then right here, that is like a full square. There's one there. I'm going to count that one there. Let's go with 1, 2, 2 there. And then 1, 2, 3, 4. 1, 2, 3, 4. All right, so we're just kind of estimating this, okay? And you're not going to see something, you're probably not going to see something like this in the ACT that much, but I'm just going to kind of go through and talk. We're going to start at the bottom down here. So what I see is 4 squares there, right? Okay, so that's an area of 4 squares, or feet squared or meter squared, whatever they are. So that's 4. Actually, we'll go up. Let's go 5, 6, 7, 8, 9. Wait, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So I've got this side over here. We have 19 squares. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, and I think we have 33 total squares. Now we're just going to estimate. I'm not going to spend a whole lot of time on this because we need to move on to the next question. But let's look at this. See, I made a frequency table as I was counting. I was making tick marks as I was going so I wouldn't lose track of where I was. So 5, 10, 15, 16, 17 total triangles. And then we have 33 squares. So that means, now remember, it takes 2 triangles make 1 square. So in this case, we would have to divide the number of triangles by 2 to get the number of squares. So 33, our area is going to be 33 plus 17 over 2. And the best estimate we can get here is going to be, let's see what 17 divided by 32 is. 17 divided by 2, I'm sorry, is going to be 8.5. And then add 33 to that, we get 41.5. So if you were to estimate this, this shape would be an area of 41.5 squares, okay? So you might see something like that if you're out on the work site where it's kind of crazy shaped like that. Some people's property lines are very, very crazy like this, okay? Because you might have a fence line coming in here that's on a neighbor's property and you can't, you know, all that kind of stuff. It's just if you're a surveyor, so I'm going to put, if you're a surveyor, you might come up on that kind of stuff. And it gets kind of tough, but you can sit there in the hot truck and calculate all your calculations and make all your money out on the field if you like that kind of stuff. So let's go perimeter. Let's go. Now what I'm going to do is I'm going to follow this line. I'm going to start at a certain point, and we're just going to add up all the sides. I just want you to understand what perimeter is, okay? So I'm going to start here at this corner. Let me clear that up. So we've got 1. So I got 1. I'm going to start here 0, 1, 2, 3, 4, 5, 6, 7. Then I come down. That's 7 across. So I'm going to draw a shape that's 7 across here. Okay, and then it comes down this way. So you're not going to be able to really calculate with the squares. This right here, we're going to estimate the best we can. Okay, and in this case right here, this is, wow, this is complex, right? So we've got, I want you to understand something. So in algebra, you need to memorize a few things about right triangles, because you're going to see right triangles a lot. If you'll notice, this is a 1 by 1. This is a 1 by 1 triangle. This distance right here, if you use Pythagorean Theorem, is, let me kind of give you a little hint over here. You're going to need to see this. Now, I didn't really pay much attention to this until I got into, you know, upper level college classes like college algebra and stuff like that. But if you have 1 and 1 like that, this distance from here to here, it's going to be 1. Then you multiply it by the square root of 2, okay? If this distance here is 2 and this distance here is 2, if these two are the same, if this is an isosceles triangle, this hypotenuse here is going to be 2 times the square root of 2. So do you see a pattern here? So if I go over here and put 7 and 7 like that, that's an isosceles triangle here. The distance for the hypotenuse, if this is a right triangle, is going to be 7 square root of 2. So you need to understand where my mind is going when I see this kind of part here, right there. I know that distance automatically because I've memorized it over the years. And this is a 1 by 1 square. So that's going to be 1 square root of 2. So I'm going to come over here on the perimeter and put 1 square root of 2, just like that. I'm bending a line down. I'm just trying to estimate and freehand this shape. So 1 square root of 2 goes right there because of this 1 by 1 situation here. Okay. Use Pythagorean Theorem to figure that out. If you want to prove me right or check my work here, you can use Pythagorean Theorem and say a squared plus b squared equals c squared and solve for c, and you'll notice that you get that. Okay, and it works every time. It's a good rule of thumb memorization tool that you can use to save some time here. Okay, so in this case, so I'm thinking from here. Okay, from here down and all right. Let's see what we got here. Let's see how we can figure this out. So from here down and over, I'm looking at this like a triangle, and I'm trying to find that slanted line, which would be the hypotenuse of this right triangle. So we're going to be using Pythagorean Theorem a lot here. So this is a 2 by 1, 2, 3, 4. You know, this little curve is kind of the problem, isn't it? So you've got this 1 square root of 2 situation going on here. Then you got this curve going on here. And then this triangle really doesn't start here. So this curve is going to skew our data a little bit, okay? But it's okay because we're probably going to be adding some things as we go. So I'm not going to worry too much about that. So we're going to come down here and go 1, okay, that's 1, 2, 3, 4, 1, 2. So it's a 4 by 2 right triangle, right? So 2 squared plus 4 squared, that's 4 plus 16, that's 20. So the square root of 20 is this right here. So this length right here is going to be the square root of 20, okay? So the square root of 20. So we're just estimating that. Now notice that that's not simplified. We'll have to simplify that. Now, let's simplify that now. So that would be 2 square root of 5. Now, the simplified version of square root of 20, how did I get that? That goes from 4 times 5, which is 20. 4 is a perfect square. So the square root of 4 inside the radical would come out and become 2 on the outside. Square root of 4 is 2. And that square root of 5 is the smallest prime number that would be left here. So this is called simplified here. So if I were adding these sides here, I would add, for perimeter, I would add 7, square root of 2, and 2 square root of 5, just for that side, okay? Now, this one problem is kind of a little more than I expected. So anyway, let's move on. So we're now at, we've started at this corner. We got 7 all the way across. We got square root of 2 there, and then 2 square root of 5 here. So we should, to that point right there, okay? Now we still have this curve to go around. That means we must have a 1. Okay, we're running out of time. This class goes so fast. Okay, so we'll start right here tomorrow and wrap up. Wait, we've got some time left. If I get cut off, it's okay. We'll start here tomorrow or wherever I stop. Okay, so if you look at this like a triangle here. See, you got a length of 1 here and a length of 1, 2, 3 going out to this point right there. So that's a 1 by 3. Now we're doing Pythagorean Theorem in our head here, okay? So you got 1 squared, which is 1, and 3 squared, which is 9. 1 plus 9 is 10. So this length from here to here is the square root of 10. So I'm going to come down here and draw out the square root of 10. And obviously that's not simplified, is it? So we're going to have to simplify that out the best we can. So that's 2 times 5. Actually, that is simplified. That's as simplified as it's going to get, okay? Because you can't, the prime factorization of this would be 2 times 5, and you don't have any perfect squares in there, okay? So I'm going to circle the parts that we would add together. So we got 7, square root of 2, 2 square root of 5, and square root of 10, okay? Now, let's move over to the next part and kind of keep going where we're at. So we're estimating, but we're estimating to the best that we can by using Pythagorean Theorem, okay? And I'm talking you through the steps so that you won't get too confused. Now, if you'll notice, from here to here, this is a length of 1, so I can go ahead and add a 1 to my shape. I'm going to add a 1 and circle that so I can keep up with what I'm going to add at the end, okay? And so now we're at this point right here, right there on the y-axis. Okay, and so now we're going to, and so that was a 1. So now we've got, well, look at this. We've got a triangle situation going on here. And then we've got another, we can kind of consider this one big triangle and think of this like one long hypotenuse. I think that's the best way to do this. So we've got a 2 by 2, and by now you should see that this is isosceles here, 2 by 2, and you can estimate this length from here to here using the rule, the little trick that I was talking about right here. See the 2 by 2? You always take that side length if they're even and are the same and multiply it by the square root of 2, and that's the trick that you use every time. Okay. So in this case, it saves you from having to do the Pythagorean Theorem a billion times, okay? So I'm gonna go draw this little line down here and put, what do we say, 2 square root of 2? Circle that, and we're gonna add that to it. So all this adds up to be the perimeter at the end. And yes, it's gonna have square roots and craziness in it, but hey, we're gonna learn how to do this. Okay, so now we've got this situation here. We stop there. If you'll notice, this is kind of a one full square, so I can go out 1 there. So I'm gonna go 1, and then right here, this is gonna be one square chopped in half there. That's a triangle. So that's a 1 by 1. So this is gonna be 1 square root of 2. So what's gonna be, what I'm gonna do here is I'm gonna draw a 1 and circle it, and then I'm going to do a kind of crooked thing and do 1 square root of 2 right there. So that's the next one. So you're going to add up all these circles together. All right. Isn't this fun? It's just like a puzzle. It is just great. Okay. All right. Now let's go to the next one. I think I would count this as a full square. I would count this as a full square here. So I would go 1 and then start from here. I know it doesn't, there's nothing there, but I would start from here and try to figure out the distance of this, which would be the hypotenuse of this right triangle right here. So this would be a 1 by 2, and we're going to figure out the length of what a 1 by 2 would be here. Okay, so we're going to go 1 and then figure out the hypotenuse of a 1 by 2. Let's go do that real quick. So we've got, what did we say? 1 was straight up. So we're going to have a 1 straight up, just like that. And then we got this little crazy slant thing going here. Now, this is not going to be drawn accurately, but so what do we say? This was going to be a 1 by 2 triangle here. So now I'm going to do this one just so you can see what's happening in my mind over here. Okay, so we're doing a 1 by 2. So if you were trying to find this length, this slanted line right here, you would square the A term and the B term and to get your C term, but you can't get the C term unless you square root everything. So the square root of, this is 1 times 1, this is 2 times 2, so that's 1 plus 4, that's the square root of 5. So this right here, I guess supposedly you could memorize that if you wanted to, but there's no real point in that. 1, 2 square root of 5. Okay, so this right here, this length is going to be the square root of 5, and I'll circle that, and we're going to move on to the next section. Okay, now this was just scratch work here. Okay, I just wanted you to see where I'm going with these notes. Now, tomorrow, if the time cuts off on me and I can't finish this problem, I'll go back and show you the notes really quickly, and you can copy them and email them to me. No worries, right? Okay, so we've still got this crazy mess in the middle that we hadn't figured out. We got all this junk, right? So now we've got to go over here and figure out where we're at and then figure out what's going on here, okay? So we've got this little nose sticking out. Looks like a cartoon nose. All right, we're at this point right here. We're going to go out 1 and then up 1, 2. So that was real easy. Out 1, up 1, 2. So we're going to go out 1, then up 2, just like that. So we can't forget to add that 1 right there at the end, okay? So we'll go out 1 and up 2. We're making that nose shape. All right, now we're up to here, and we got to figure out what this distance from here to here is. Let's back this up. So this is a 1 by 1, 2, 3 triangle here. And we need to find the length of that hypotenuse. So this is 1 by 3. Let's do this in our heads. 1 squared is 1. 3 squared is 9. 1 plus 9 is 10. So this is going to be the square root of 10 right here. Okay. So this little length is going to be the square root of 10, and I'm going to circle that. Okay. Right there. So we'll come in. That's going to be the square root of 10. And that's simplified, like we said over here. There's nothing we can do to make that any better, and move on, okay? All right, hidden perimeter, great. All right, so let's go to this right here. So we've got this distance that comes from here to here. This is the last little bit of distance that we have to calculate. So we're going to figure out what the dimensions of this triangle are. It's a 1, 2, 3 by 1, 2, 3. Hey, 3 times the square root of 2. All right, so let's go. So this right here, super easy. 3 times the square root of 2 now, since we know that that was a 3 by 3 isosceles triangle there. Okay, now let's pull this back. All right, let's clear this up. This is a lot of mess, right? What we're doing is estimating the area and the perimeter of this crazy shape, okay? So it's not exact, it's estimated. So what I'm going to go through and do is I'm going to add up all the whole numbers, then I'm going to add up all the square roots of 2, then all the square roots of 5, then all the square roots of 10. And I'm going to put them in a big chunk. So let's do the whole numbers. 7 plus 1, that's 8, 9, 10, 11, 12, 13. So the whole numbers are 13. Then we're going to come over here and add up the square roots of 2. So that's 1 square root of 2, 2 square root of 2, that's 3 square root of 2, 4 square root of 2, 7 square root of 2. Okay, so when I add all those up, then we're going to add up the square root of 5. So we're going to go around and do 2 square root of 5, 1 square root of 5, that's going to be 3 square root of 5, and that's it, 3 square root of 5. And then let's go do the last one, which is the square root of 10. Is the only one we have left. The square root of 10, there's one of them there, 2 of them there. So 2 square root of 10, okay? So how does this all work? All right, how would you do this?